6 review. This is in preparation of our test. This is for Math 7, and our topic for this unit was proportions and similarity. So as you guys are going through this assignment, I wanted to kind of give you some guidance. So if you're needing to watch this video for some guidance, please feel free. This is a great way to use some resources to prepare for your exam, and we'll go from there. All right, so to begin with, we've got part 1, multiple choice. Our first question, what is the value of x in the proportion? Remember, when we're solving proportions, we always want to begin by cross-multiplying. So I'm going to go 9 times x, and I'm going to set that equals to 6 times 12. You can also write 12 times 6. I'm going to get 9x, and here I'm going to get 72. Going to divide by 9 on both sides, giving me x is equals to 8. That tells me that A is my answer. Moving on to number 2. Trevor bought 5 packages of cake mix for $22.50. How much would 8 packages of cake mix cost? For this problem, we are going to need to create our own proportion, and it's going to be packages over dollars. So here, Trevor bought 5 packages for $22.50. We want to know how much 8 packages would cost. So our x is there. I am once again going to begin by going and cross-multiplying. So I'm going to get 5 times x is equals to 2250 times 8. $22.50 times 8 is 180, and I get 5x here. I'm going to divide by 5 on both sides, and x will leave me with 36. So that tells us that our 8 packages will cost $36, or C. Next is number 3. Question 3 says, Vanessa ran 3 laps in 8 minutes. How long will it take her to run 10 laps at this pace? Once again, we're going to need to create our own proportion, and we're going to go laps over minutes. So here, Vanessa ran 3 laps in 8 minutes, so I'm going to go 3 over 8. And I'm going to set that equals to 10 laps, so our 10 goes up top, over x. Now, once again, we're going to cross multiply, so we get 3 times x equals 8 times 10. We get 3x equals 80. We're going to divide by 3 on both sides, and 80 divided by 3 is going to go ahead and give us 26 2/3, or 26.66. That 6 is repeating, and 2/3 is our equivalent of that. So our answer is going to be B. Number 4. Triangle mat is similar to triangle rug, RUG. Which side of triangle rug corresponds to side MT in triangle MAT? So we're looking at MT, which is the corresponding side on our triangle rug. That is going to be down here on the bottom, RG, and that happens to be D, our answer. Number 5. What is the scale factor for the similar figures? When we talk about scale factor, we talk about setting corresponding sides over each other and writing our answer in simplest form. Here, we get 18 over 24 because they're both on the bottom of our hexagon. That's a 6-sided figure. Okay. So here, the number that goes into both 18 and 24 is 6. So I'm going to divide each one of these by 6. When I do that, I get 3/4. Now when we write a scale factor, we write it in a colon form. So we get 3:4, and that gives us an answer of C. Number 6. What is the value for y in the similar figures? Here we're going to go ahead and create a proportion using corresponding sides. So that means I'm going to set my my 20 over my y. Because they're both on the left side of our rectangles, we're going to go ahead and set them over each other. So it's going to be figure 1, which is 20, over figure 2, which is y. And I'm going to set that equals to figure 1 on the bottom, which is 25, over figure 2 on the bottom, which is 10. Once again, I'm going to cross multiply. So that's going to give me 20 times 10 is equals to 25 times y. I get 200 equals 25y. I'm going to divide by 25 on both sides, and I get 8 equals y. That gives us an answer of C. Next, it says 2 triangles in number 7. 2 triangles have a scale factor of 2/3. The smaller triangle has a perimeter of 14 inches. What is the perimeter of the larger triangle? So once again, this is 2 different triangles. Okay. The smaller triangle has a perimeter, meaning the distance around our figure is 14 inches. What is the perimeter of the larger triangle? Now we know that our scale factor is 2:3. That means that this is our small and this is our large. So we can use that scale factor to help us find the perimeter. And we can do that by going 2/3. Excuse me. And we can set that equals to 14/x. Now here, we are going to go 2 times x, which is 2x, and 3 times 14, which is 42. We're going to divide by 2 on both sides, and that's going to give us x is equals to 21. Now, the reason why I'm using the 2:3 as my scale factor to help me create my proportion is because this is already comparing my small figure to my large figure. So here, the 2 would indicate that it's our small figure. The 3 would indicate that it's our large figure. Since I know that 14 is the perimeter of my small figure, I can use those pieces of information to find the perimeter of my big figure. And in this case, the perimeter of the bigger figure is 21 inches. Moving on. Next, here we go. So now officially we're in the free response. This is where you're going to need to make sure that you're showing your work as you're going through this. So here we go. Solve each proportion. Once again, please write your name at the top of each page. This way I know whose it is in case for any reason the pages get separated. It just makes things a lot easier for us as teachers when we're grading this stuff since we don't have you in person. So to solve this proportion, remember we're going to begin by cross multiplying. So I'm going to go 3 times x, and I'm going to set that equals to 4 times 12. 3 times x is 3x. 4 times 12 is 48. We're going to divide by 3 on both sides, giving us x is equals to 16. So I'm going to write 16, and I'm going to circle it. Next, for number 9, we have 15 over 25 equals y over 30. So I'm going to cross multiply again. 15 times 30 equals 25 times y. I know that 15 times 3 is 45, so I'm going to add a 0. That's a shortcut for us when we have to multiply large numbers. So I'm going to get 450 is equals to 25y. I'm going to divide by 25. Now I know that 25 can go into 100 4 times, so 4 times the 4 would give me 16. And then 25 can go into 50 twice, so 16 plus 2, that'd give me 18. So 18 is equals to y. And once again, we're going to circle our answer. All right, number 10. Tyson bought 4 roses for $8.88. How much would 6 roses cost? This is where we're going to have to create our proportion. So once again, Tyson bought 4 roses for $8.88. So I'm going to put roses over money. So Tyson's 4 roses for $8.88. And we want to know how much. If we're talking how much, that's going to mean money, so that's in the bottom. And the 6 roses would be up top. So we're going to go 6 times 888. And that's going to equals 4 times x, or 4x. Now 6 times 888, if my calculator will cooperate, which you are free to use, is $53.28. All right, so we get 4x equals $53.28. I'm now going to divide by 4 on both sides, and that's going to give me $13.32. So x equals $13.32. So that tells us that 6 roses, so we're going to write 6 roses would cost, and we need to use words here because this is a word problem. So 6 roses would cost $13.32. And there we go. That's our answer. All right, number 11. Mia ran 10 laps in 8 minutes. Shauna ran 4 laps in 3 minutes. Which person ran a faster rate? So here we're going to need to figure out what our lap per minute ratio is. So we're going to set this all as laps over minutes. Now Mia ran 10 laps in 8 minutes. So when we go 10 divided by 8, that's, in this case, 1.25 laps per minute. Okay. Now Shauna, she ran 4 laps in 3 minutes. When we go 4 divided by 3, we get 1.3 repeating laps in 1 minute. Now our question is, who ran it faster? When we talk about running fast, we want the shorter amount of time. So in this case, who ran at a faster rate? While Mia ran 1.25 laps in a minute, Shauna was able to complete 1.3 repeating, or 1 1/3 laps in a minute. That means that Shauna ran at the faster rate. So we're going to write Shauna ran at the faster rate. And there we go. All right, number 12. So for number 12 and 13, we're looking at our scale factor for each pair of similar figures. So it already tells us that these figures are similar, so we don't have to prove that. What we do need to do now, however, is we need to make sure that when we're writing our scale factors out, we're comparing it from figure 1 to figure 2. Okay? So I want you guys to make sure that you write that we're comparing figure 1 to figure 2. This last week I saw that several of you compared the information on each figure to the other figure. So you'd go in number 12, 8 over 12, and then 12 over 18. That doesn't give us our scale factor for the 2 triangles. Okay? So what we're going to need to do is we're going to need to make sure that in this, that was a really poor example because I just noticed that these 2 numbers are similar. Okay, but here what I'm going to need to do is I'm going to need to take my 8 inches and I'm going to need to compare it to the 12 inches on the other figure. I can't compare it on the same figure. And that's what I was trying to say earlier. Okay. So here, we need to make sure that when we're writing our scale factors, we're writing it for what are called the corresponding sides, or the parts on the different figures that are on the same part of that figure. So here I'm going to have 8 to 12. Now when we write our scale factor, we always talk about it being in simplest form. Now 8 can be divided by 4 and 12 can be divided by 4, so I'm going to use 4 to make these two numbers smaller. So here, when I divide by 4, I get 2. When I divide by 4 here, I get 3. So far my scale factor is 2/3. I'm going to use the 12 and the 18 on the bottom of my figure to do the same. Now I'm doing these in different shapes to show that I'm comparing one figure to the other. So here I'm going to go 12 to 18. The same number that can go into both 12 and 18 is 6. So when I divide each one of these by 6, I get 2 and I get 3. So that means that our scale factor is 2/3. All right. Over here on number 13. Once again, we're comparing figure 1 to figure 2. So here, I'm going to compare my 15 m for meters to the 12 m for meters. So 15 to 12. So here, the number that goes into both 15 and 12 is 3, so I'm going to divide 15 by 3, and that's 5. I'm going to divide 12 by 3, and that's 4. So it's looking like my figure is going to have a scale factor of 5/4. Now I could use a different set of numbers. I could use, and I'm going to use a squiggly for this, I could use 20 meters and 16 meters. Now I can use that because the same number that goes into both 20 and 16 is 4. So 20 divided by 4, that's 5. 16 divided by 4, that's 4. So once again, we get the same scale factor. Now, I'm not using my final set of 15 and 12 here because I already have one set of that here. So our scale factor is going to be 5:4. Moving on to the next page. All right. For this figure, we are identifying the corresponding sides and the corresponding angles. So if I'm taking a look at side, or in this case, triangle RAT, okay, I want to find the side that corresponds to RA. So RA is here. That's going to leave me with BU. Once again, I need it to be on the same side of the similar figures, okay? Or in this case, yet to be determined similar figures. So RA is corresponds to BU. So I'm going to write BU, and I'm going to put a line underneath it because that is side BU. Next, side AT. That's on the bottom of my triangle. I'm going to look for the side that's on the bottom of my other triangle, and that's UG. So I'm going to write UG, and I'm going to put my line over the top. Lastly, RT. So RT happens to be the hypotenuse, or the longest side of this triangle. BG is the longest side, or the hypotenuse of my other triangle. So I'm going to write BG with a line over the top. Now looking at my angles, okay, I want to compare angle R to its corresponding angle. Now if angle R is up at the top of my triangle, I'm going to look for the angle that's in the other triangle that's also at the top, and that is angle B. So I'm going to write a B right here. Now if we look at their dimensions, they're also both 60 degrees. And this equal sign with our little swirl above it, that means that it's congruent, meaning they are equals to each other. Next, if we're looking at angle A is congruent to angle U. They both have a right angle. That means that they are both 90 degrees. So angle U. And then lastly, angle T is congruent to angle G. Angle T is 30 degrees. So angle G is also 30 degrees. Now in this case, it's asking us our angle is triangle RAT and triangle BUG congruent, similar, or neither. Here, our triangles are congruent. The reason why they're congruent is because they all have the same angles and they all have the same side lengths. Our RA's and BU is 9. The AT and the UG is 12. The RT and the BG are both 15. So in this case, they are congruent. Next, we're taking a look at number 15 and 16. So here we're using the shapes below, and we are determining what our missing value is. We're solving for each variable. So remember, we want to make sure that we're using corresponding sides. So we're going to go figure 1 to figure 2. Okay. So on this, I'm going to go 10 to 20. So 10 over 20. And I'm going to set that equals to 11 over A. Now, I'm going to cross multiply. So I'm going to go 10A equals 11 times 2 is 22. And I'm going to add a 0, so 220. Next, I'm going to divide by 10 on both sides, giving me A is equals. I'm going to cross out the zeros. That's going to leave me with just 22. So I'm going to circle it. A equals 22. Next, we have 16. Here, we're going to take the bottoms and set them over each other. Because again, figure 1 to figure 2. So I'm going to go 18 over 6. And I'm going to set that to x over 7. I'm going to multiply. I'm going to go 18 times 7 equals 6x. This is going to be 126 is equals to 6x. I'm going to divide by 6 on both sides. And that's going to leave me with x is equals to 21. All right, number 17. Victor wanted to know the height of a tree at his friend's house. On Saturday morning, he measured the shadow of the tree along the ground to be 24 feet. So this little triangle here is our tree. Okay. This is our shadow. And he wanted to know the height of the tree. So this is the height. And we don't know it. At the same time, he measured his own shadow to be 3 feet long. That's where we see the 3 feet here. So this is Victor. And again, this is his shadow. Victor is 6 feet tall. So this is Victor's height. Here. Find the height of the tree. So, I'm going to take my heights and I'm going to set them equal to the shadow. So I don't know what the height of the tree is. So I'm going to set that as my x. I'll actually make that look like an h. So here we go. So x for my height over 24. The length of the shadow. Now I'm going to set that equals to Victor's height, which was 6 feet, over the length of his shadow, which was 3 feet. Now I'm going to go ahead and I'm going to multiply diagonally. So we're going to get 3 times x equals 24 times 6. We're going to get 3x is equals to 144. We will divide by 3 on both sides. And that is not a number I know off the top of my head. And that will be 48. So x is equals to 48. Now we need to remember that this is a word problem, so we need words in our answer. So here we're going to write the height of the tree is 48 feet tall. And there we go. We've officially answered the problem. Lastly, we're going to go ahead and do our final page of the review that I will be covering with you. Now, there is one additional page, but that happens to include an extra credit problem, and I don't think it's fair for me to give you the answers to the extra credit problem. So, we're going to go ahead and just end with 18 and 19. So here, we're going to use the figures below to find the scale factor, the ratio of the perimeters, and the ratio of the areas. Now, I want to remind you that our scale factor is A to B, meaning figure 1 to figure 2. The ratio of our perimeters is the same thing. It's the ratio of figure 1 to figure 2. The ratio of the areas is our figure 1 squared to our figure 2 squared. So, let's find our scale factor. We have 28 and 21. So let's simplify 28 and 21. Now the same number that goes into both 28 and 21 is 7. So I'm going to divide each number by 7, and that's going to give me 4 over 3. Now 4 over 3 is in its simplest form, so that is going to be our scale factor. Now the ratio of the perimeters, that's exactly the same thing again. So it's going to be 4:3. Now the ratio of our areas is our scale factor squared. Now squared means we're not timesing it by 2. We're timesing it by itself. So I'm going to set it as 4 squared to 3 squared. Now 4 squared is 4 times 4, and that's going to be set to 3 squared, which is 3 times 3. Now 4 times 4 is 16. 3 times 3 is 9. So our ratio of the areas is 16 to 9. All right, lastly, here we go. So it says 2 similar triangles have perimeters of 10 inches and 30 inches. Now these are similar triangles, so I'm just going to go ahead and draw 2 different triangles. One obviously bigger than the other, and I'm going to write 10 inches inside, and I'm going to write 30 inches inside. Because again, these are the perimeters. So the ratio of their perimeters. Well, the ratio of their perimeters is their scale factor. So I'm going to write 10 to 30, and I'm going to simplify it. That's 1 to 3. So our ratio of their perimeters is 1:3. Now their scale factor is once again the same thing as the ratio of the perimeters. So here, that's 1 to 3. Now the ratio of the areas. Once again, this is our figure 1 ratio squared to figure 2 ratio squared. So I'm going to go 1 squared to 3 squared. 1 squared is 1 times 1. 3 squared is 3 times 3. So 1 times 1 is 1. 3 times 3 is 9. So our ratio of their areas is 1 to 9. Lastly, here it says the smaller triangle has an area of 4 inches squared. Find the area of the larger triangle. Now, for this, we're going to go ahead and use their scale factors to help us in this problem. So, we have our scale factor, which is 1 to 3. And then we have our area of the smaller triangle, which is 4 inches squared. This 1 is our small triangle. This 3 is our large triangle. So, let's multiply them. Here, we're going to go ahead and use, once again, a proportion. So we're going to go 1 over 3. Oh, I'm sorry. We need to go ahead and use the ratio of their areas since we're finding their area. I apologize. So this should actually be 1 to 9. 1 to 9. I am very sorry about that. So once again, because we're finding the area of the larger triangle, we need to use the ratio of their areas. Okay? So this is 1 to 9, or 1 over 9, and we're going to set that equals to the area of the smaller triangle, which is 4, And what we need to find is the area of the larger triangle, so we're going to set that as x. Here, I'm now going to go and cross multiply. So I'm going to go 1 times x, and then I'm going to go 9 times 4. 1 times x is just x, because it's implied that by having an x here, we have one of them. And then 9 times 4 is 36. So that tells us that the area of the larger triangle is going to be 36 something. Now that something is also going to include an inches squared. So I'm going to write the area of the large triangle. Now I'm going to use a triangle here instead of writing the word triangle. I'm going to write is 36 inches squared. Anytime we talk about area, we always need to make sure that we're including those inches squared. All right, now if you have any questions about this review, please send me a message, leave me a comment. I am here to help any way I can before you guys take your test. This has been Mrs. Ross Does Math. Thank you so much for watching.